First, I placed the button on the board. One side of the button is connected to the positive line so it can receive power when pressed. Next, we insert a resistor. This helps to limit the current. Then, we place the transistor and connect its base to the resistor. After that, we add another resistor. This resistor is connected to the collector of the transistor. Now we connect the LED light. One side of the LED goes to the resistor. And the other side goes to the negative line because the current flows to the negative side. Finally, we connect the emitter of the transistor to the negative line as well. After all connections are done, we test the NOT gate. When we press the button, the light turns off, and we release it, the LED turns on. That means our NOT gate works correctly.
Hello. Let's start with the first one, which is NOT gate. Since this is a NOT gate, if you don't push any of the buttons, it turns on, the LED turns on. Electrons start from positive and come here, and since we haven't pushed the button, the electrons will not be able to collect it in the base of this transistor, so we will not have electrons will not be able to pass here. Then what will happen? They will continue from this resistor and pass LED. So it will always be turned on if we don't push the button.
And now let's see why LED turns off when we push the button. Let's see. Electrons has two different ways. So look at the first one. In this one, if we push the button, they will be able to go through this resistor to the base of this transistor. So there will be energy in this transistor. Therefore, electrons which come like this, they will be able to collect from this transistor and emit and go to the negative. Therefore, there will be no electron pass the LED. So LED turns off.
Let's continue with the AND gate. First, we place two buttons on the breadboard, and we connect both of them to the positive line. Next, we add two resistors. These resistors are linked to the bases of each transistors. Then I connect the emitter of the transistor to the collector of the transistor. After that, the emitter of the transistor goes to the negative line. Now I place another resistor and connect it to the collector of the transistor using a wire. Then I add one more transistor and connect its base to the resistor. And we add another resistor. This resistor is connected to the collector of this transistor as well. Next, we placed the LED light and connected it to the resistor with a cable. The other side of the LED light goes to the negative line. And finally, we connect the transistor's emitter to the negative sides too. After connecting the power supply, we can test it. We can see that the LED only turns on when both buttons are pressed at the same time. That's because this is AND gate.
Now let's continue with AND gate. Since this is an AND gate, if we don't push any of the buttons, electrons will not be able to pass and will turn the LED on. But let's explain this process. The electrons start from positive and come to here, and since we haven't pushed any of the buttons, they will not be able to be collected in the transistors, in the base of these transistors, so we exclude this side. And electrons come here, they pass this resistor and come to the base of this transistor. So when the other electrons come here and pass the resistor and collect, the transistor collects and emit those electrons, so we have electrons which can come to the minus via this path. So we will not see this LED turned on in this situation. But again, if we push either one of the buttons, it will not work again. It's because these two transistors are related. So if we push one of the buttons, they will not work again. So this process will repeat itself, and the LED will not turn on again.
So let's now see why this LED turns on when we push both buttons. As these transistors sequentially connected, if we push both buttons, electrons will divide into two groups and will be collected in both bays. So other electrons which come like this, they will be able to pass both transistors and go to the minus. Therefore, there will be no energy in this transistor. That's why electrons which come from here, they will not be able to pass this transistor, and only way for them will be through this LED. That's why this LED will be turned on.
Let's continue with the OR gate. First, we place two buttons on the board and connect them to the positive line, because both buttons will receive power from there. Next, we add two resistors and connect them to each button. These resistors are linked to the base of two separate transistors, and we connect both emitters of the transistor to the negative line. After that, we place another resistor and connect it to the collector of the both transistors. Now we add one more transistor and connect its base to that resistor. The emitter of this transistor also goes to the negative line. Then we place another resistor and connect it to the collector of the last transistor. Next, we attach the LED light. One side of the LED is connected to the resistor and the other side goes to the negative line. Finally, when we press either one of the buttons or both of them, the LED turns on. This shows that our OR gate works correctly.
Now let's finish with an OR gate. Since this is an OR gate, if you don't push any of the buttons, the LED will not turn on. And let me demonstrate it. When we start from positive, The electrons come here, and since we haven't pushed any of the buttons, they will not be able to collect it in the bases of these transistors. So we need to exclude this side and continue from here. The electrons come here, past this transistor, and they will be collected in the base of this transistor. And that will happen always. They will be able to go to the minus. So the LED will not turn on never, because none of the electrons come and pass the LED.
And now let's see why we push one of these buttons and both LED turns on. Let's see. As we know, electrons has three different waves here, and if we push at least one of these buttons, as these transistors connected parallel, so if we have at least one of these transistors energy, then electrons which come from here, they will be able to go through at least one of these transistors, and they go to the minus. So the electrons which come from here, they will not be collected in the base of this transistor. Therefore, the last way for electrons is through this resistor, and as there's no energy, the only way for them is through this LED, so the LED will be turned on.
Başlayaq inşallah.
Tam əminsən də Vüsal hissin.
2 hours later.
Hello deyin də. Səhvdir. Uzaqdan bizi çəklər. Qoy bilinsin ki, ikimiz var. Qoy sən dinləməm. Ayda, dağılış təzdən. Ayda.